Coming up on this episode of This Week in Space, we get Dr. Pascal Lee back in the chair to talk about the best place to land on the moon and build a base, and it's not the South Pole. Tune in. You're going to want to find out where it is.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 148, recorded on February 14th, 2025, Clavius Base. Hello and welcome to yet another episode of This Week in Space, the Clavius Base edition. I'm Rod Pyle, editor-in-chief of Astro Magazine. I'm joined by my bestie, Tarek Malik, editor-in-chief, award-winning editor-in-chief.
Award-winning,
soon
thank
to stack
you.
up another one at space.com. Hello, partner.
Hello, Rod. How's it going? Happy Valentine's Day, Rod. Happy Valentine's Day.
Happy Valentine's Day.
Will you be my Valentine? My space Valentine?
Moving on. We're joined by the ever-impressive Dr. Pascal Lee, whose scientific reputation is growing faster than the CUDSO on SLS's mobile launch structure. Hello, Pascal. How are you?
Oh, too soon.
I'll take that as a compliment. Hi, everybody.
Hello.
Thank you.
Before we start, as I always say, please don't forget to do us a solid. Make sure to like, subscribe, and all the other podcast things, because we love you and we need to know you love us just as much. So keep us fat and happy, and we'll thank you forever. And now, from the uncertain mind of me with a nudge from Mark R. on Facebook.
Mark.
Hey, Tarek.
Yes, Rod.
In the spirit of renaming bodies of water near Florida, what has Elon decided to rename Mars?
I don't know. What has he decided?
Planet X.
I get it.
Get it? You're not laughing much. Okay.
Well, I mean, I get it. Do I want to laugh? I don't know.
I've heard that some people want to rename us to something unflattering when it's joke time in this show, but you can help send your best, worst, or most indifferent space joke to us at twist.tv, because obviously we need the help. All right, let's do some headlines. Pascal, feel free to jump in anywhere you wish.
Headline news.
I did it.
Oh, bingo. Pretty good.
Yeah, but you didn't do it with an Australian accent. Hey, what's going on at Blue Origin, buddy?
Yeah, your guess is as good as mine, but it's really sad that we found out that they decided to lay off 10% of their workforce. There's a bunch of reports out this week. The one that we've got cited here is from Karen Weiss and Ken Chang over at New York Times. Hey, they're both K names. That's interesting. But they got this memo from Dave Limp, the CEO of Blue Origin, who basically said that they're going to cut 10% of their workforce, about 1,000 jobs is what it looks like, in order to, I guess, refine or cut what they see as excess now that they need to shift into true operational flights. You know, just last month they launched their very first New Glenn rocket. They did not stick the landing. They're trying to launch the next one in maybe like the spring, is what we found out, because there was a commercial space conference in DC this week where Dave Limp was talking, and that's what he said there, to according to our writer Mike Wall. But I guess to make that goal, they're going to scale up their manufacturing and launch cadence and reduce what they see as like overages in management, in design, and that and research and that sort of thing.
Including
it is very
upper management, they said, right?
Exactly. Yeah, they said. I just had it here. But it's like upper management and a lot of like the research types of things, but I guess they don't need that anymore because they've got the rocket that they're ready. And allegedly, Blue Origin is planning to launch like a moon lander by the end of the year, right? To show that they can do it. And it's a cargo version of it, and they want to focus on that right now. And there was a very interesting citation in the story, and then we can move on. But they were talking about why New Glenn was so delayed and why they brought in Dave Limp, because he replaced the previous CEO, to try to turn things around. And the observation from Chad Anderson at Space Capital was that Jeff Bezos was just pumping in $1 billion a year into it. They didn't have to rush anything because they had all this money that they were flush for research, and so they were like locked in a permanent like R&D phase, and they didn't feel that urgency. That's what Dave Limp was brought in to change. So this could be part of that, to get them to catch up to SpaceX because SpaceX's Falcon rockets and now with Starship have such a lead on them in commercial markets.
All right. Moving on to the next story, which is space.com.
Yes.
Scientists are alarmed as the Vera Rubin Observatory changes the biography of the astronomer Vera Rubin, after which it is named, amidst the current administration's push to streamline DEI. Well, I'm being polite, to eliminate references to DEI on anything NASA and government. Did I get that right?
Yeah, this is a really disappointing, but this was actually first reported by ProPublica as well last month. But our writer Sharmila Kuthner followed it up with some really great interviews with scientists. They're extremely upset because, as we all know, we're in this new administration with the Trump office, and they did issue that executive order to all federal government agencies to scrub their DEI programs, to end them or whatever. And part of that has been to change or remove websites and pages and that sort of thing that celebrate any kind of diversity, equality, etc. Types of programs.
Equity.
And what ProPublica found, and our writer followed up on, is that the Rubin Observatory, Vera Rubin, has her biography there. It's named after the famed astronomer, and they've actually altered the biography to kind of remove all of the mentions of how the observatory is working to reduce barriers for women and other historically.
Well, excuse me, and significantly to not rewrite, but streamline the history in which it was said she was a champion for women in the engineering workplaces, so engineering and sciences workplace, which that was really the part that got me.
Yeah, and like when ProPublica went back and forth through what the bio used to say and what it says now, there are things taken out, like a phrase of how she advocated for women in science. It's removed. There was another paragraph that read that science was still predominantly like a male dominated field, and they took things like that out too. And it's just really strange because it seems very petty, right? Mm-hmm. To go that granular, because like who is really being affected by that when you're trying to tell what is the actual accurate history of what happened. And I think that's what a lot of these scientists are very concerned about the kind of reworking and rewriting of that science history that really doesn't paint a picture of what it actually was, what barriers actually did have to be overcome, in fact, even to this day. So it was a very interesting story. I really recommend people to not just check out this story on space.com, but also the ProPublica one, because it's a very detailed, deep dive to see how science is being affected by all of this this Trump stuff.
All right, let's keep moving quickly here. And by the way, it's diversity, equity, and inclusion, just for people who
I said equality
about that kind of stuff, which is different. This is right down Pascal's alley. We have iridescent clouds on Mars captured during Martian twilight in a RoboShot.
These are great. I kind of wanted, after that really heavy one, to find something that was really fun. And actually, if you scroll down, there's a video here, Anthony, that you can see. And these are from the Curiosity rover, NASA's Curiosity rover on Mars. And they saw these red and green tinted clouds, these night shining clouds way at the top of Mars's atmosphere. And it's just spectacular that you can see these types of colors on another planet. I mean, I've only seen night shining clouds maybe once or twice in my actual life on Earth. And the fact that we can see them on Mars just is like another example of how wondrous that planet is. They are noctilucent clouds. We do have them on Earth as well. And I think that what they did is they took a bunch of pictures over about 16 minutes or so, and then they sped them up something like 480 times the actual speed of these clouds. This is not how fast the clouds were moving on Mars themselves, but they're about 50 miles above the surface, and it's a lot colder up there. So very, very interesting to see. And I don't know, maybe astronauts will be looking at this one day in the future. I
was going to say, I expect Pascal to be one of the first to be up there and see them.
That's right.
It's really beautiful. And for your listeners who might not remember, noctilucent clouds are clouds that are simply lit from below when the sun is actually below our horizon. So after sunset or before sunrise, the sun rays can actually hit clouds that are very high up in the atmosphere. So this would work both on the Earth and Mars and in other places too. And the clouds acquire this transient, so it doesn't last very long, but beautiful glow to them. And this is what's being captured here.
All right. And as our Valentine's gift day to everybody, well, if you live far enough north, we give you the aurora borealis.
That's right. There is a Valentine's Day aurora alert because this week there was a coronal hole in the sun. That's when a hole in the magnetic field, so a lot of charged particles come out, and it triggered a G1 geomagnetic storm this week. So if you're in the United States, maybe in Michigan or Maine, you might be able to see some amplified northern lights north of that, of course. And it's just a reminder to keep looking up, because according to NOAA, this storm might actually get more intense or be repeated as that coronal hole rotates more to face the Earth over the next few days to a week or so. So keep looking up, and hopefully it'll get down to New Jersey again, where I can see it, so it's not raining the whole time.
And if you are going to look up, go somewhere dark.
Very dark, yeah.
And
no
just a
streetlights.
Reminder, this just speaking recently to friends who had seen the last round of this, and it's not like it looks on the cell phone videos. It's pretty faint, All right, a couple of quick housekeeping items. Rhiannon Jones sent in a question: why shouldn't we worry more about the 2032 asteroid? And as we've discussed a little bit on the show, it's not unusual for the first sighting to have a certain percentage of chance of an impact with Earth, and then for the next sighting to be a little higher. But as JPL and others continue observing and charting this thing and figuring out its trajectory, those numbers traditionally have gone down. That doesn't mean it absolutely will, but it probably will. And I would add, this thing's actually only about 35 or 40% the size of the asteroid that the DART mission changed the trajectory of. So we do know now, it's a couple hundred feet across. DART's was almost 600 feet across, Dimorphos. So as we know now, we can change the trajectory of these things. So if it became a risk, and if we caught it early enough, a big slam or a nudge or a tractor engine or however you want to do it would push this thing far enough off that it would probably go somewhere else, hopefully not onto the moon, but that would be spectacular to see. So even erring on the side of caution, I don't think it's something to worry about, and we probably should have made that clearer.
Just be careful at the headlines, because you're going to see a lot of headlines that say the odds of impact have doubled, and that's great because they've gone from like 1% to 2%. So there you go.
Which doesn't mean 50%. Yeah.
Yeah.
Second thing, which is for you, Tarek. We got a question from Brett Wesley, who I think is a recently retired engineer, who wants to see a Starship launch, but he says it's hard to spot when they're going to schedule them, although you do put them up on space.com, and he's wondering where the best place to view it is.
Well, so thank you so much, Brett, for the note. If you're really looking for like up to minute, like what's happening at Starbase, NASA Spaceflight is probably like the best site to look at. They have actually live cameras of what's going on there all the time. Plus they've got some dates when they think the launches are going to happen based on a lot of different sources, like the county commissioners when they do road closures and that sort of thing. SpaceX tends to not announce the launch target until very close to it. So like about a day, maybe 2 days, sometimes a week if they're feeling generous. I would say though that if they've got a rocket on the pad, you can get very close to it almost all of the time when the roads aren't closed, because you can pull up right across the street from the spaceport and look at it. The place that I would recommend watching from is from South Padre Island. It's right across the bay from the place, and there's a lot of hotels there, and you can actually walk from the hotel down to the launch site, avoid some traffic. It's not very far, but you can also get it from there's like a campground around there, the Boca Chica area, but the Boca Chica beach itself gets closed off, so you can't go there. But there's a Boca Chica camping ground that has very clear views. I've seen people camp there during the launches and watch it there too. But I like South Padre Island, and if you're flying, McAllen, Texas is the better airport. It's got more cars for rental cars. It's easier to get into and out of. So,
all right. If you have any other questions, just drop us an email, and I'll see to it that Tarek responds. Let's go to a quick break to one of our beloved sponsors, and we'll be right back. Stand by. All right, we are back with, speaking of beloved things, our beloved Dr. Pascal Lee, who's a planetary scientist at SETI, director of the Mars Institute, founder of the Houghton Mars Project, explorer, artist, raconteur, registered Francophile, I guess by long affiliation, And discoverer of Martian glaciers and volcanoes. Did I miss anything, my friend?
Yes, but that'll do it for today.
Okay. I did get artists in there. So, okay. Well, that'll do for today.
I love dogs. And my dog, Apollo here, is
Apollo!
taking a nap.
Apollo, the polar bear warning system. Yes. Hello, Apollo.
Give that dog a treat.
That dog has left more little nips on your heels than anything else I've seen. So we're here today to talk about moon base sighting, and your favorite location for that, which you've worked out pretty thoroughly, is the crater Clavius. Now, when we think of Clavius, of course, most of us, at least of a certain age, think of 2001: A Space Odyssey, where we have a massive lunar base in which the Orion spacecraft, not the Orion we know, the Orion from 1968 lands.
The Pan Am,
and
right?
No, that's the Pan Am gets to the space station, and then Orion's the moon shuttle. Young man. And,
sorry.
And moon monoliths and moon buses and all kinds of other cool stuff. So maybe you can, Pascal, just sort of give us a general orientation and primer on Clavius and why it's important.
Yeah. Well, first of all, let me preface this whole discussion with the notion that I think Artemis right now is on course to achieving great things. The idea of pushing for a base at anywhere on the moon, including at Clavius, is not to suggest that we should stop doing what we're doing with Artemis and somehow shift gears in a dramatic way. But I think that we should nudge the program as early as possible to really focus on having humans set up, having American astronauts and our partners set up a base on the moon and at an off-polar site. The polar regions are terrible to set up an exploration base. You want to set up a mine there if you find water that you can extract economically. You don't want to set up an exploration base from where you would want to roam around a lot. So therefore, we've been looking for a place to set up potentially an Artemis base camp that would be at an off-polar site. And so here are some criteria. We wanted it to be on the near side of the moon so that you can see the Earth from it at all times. You want it to be in a place that is inherently geologically very interesting. So ideally covering a long expanse of lunar history. You want it to be a wide open space where you can land and expand your base and also do lots of traverses without running immediately into a lot of terrain challenges. You want a place that can give you access to caves, because that's really what we want to do ultimately on Mars. And so for that reason alone, it's a good idea to start practicing as early as possible cave exploration on the moon. And so if you combine all these criteria together, Clavius rises to the top very quickly. Wow, beautiful. Yeah, thank you. So you're looking at Clavius from the south. It's this giant basin. It's 263 kilometers across, which is the distance between Washington and Philadelphia. The large fresher crater that's sitting on its rim in the foreground is Rutherford. And both inside Rutherford and on the ejecta blanket outside of Rutherford, there are caves, pits and caves. And the base site that we're proposing, at least to check out robotically first, of course, before you start moving a whole bunch of assets there, is right to the west. In other words, to the left of Rutherford, in that flat spot in the foreground on the floor, Clavius crater that you see here at the bottom of the page.
Pascal, if I'm looking at the moon, like because it's a full moon this week, for example,
Yeah.
right? It's a great time to look at it with telescopes. Can I see Clavius? Like
Yes.
you mentioned, so where like is it in the center? Dead heart
Lower
for
left.
people.
Lower left.
The lower left.
Yes. If you look at the lower left of the moon, at least from the northern hemisphere to the lower left, right? If you're in the southern hemisphere, it's the other way around. But you will see a very bright impact crater with bright rays, ejecta rays. That's Tycho. And straight south from there, a few Tycho diameters away, you have Clavius. So Clavius, seen from the Earth, appears to be almost at the edge of the moon, although it's still quite clear of it. Mm-hmm. If you were at Clavius, you would see the Earth well clear of the horizon, but near the horizon still. And that would be really a beautiful sight.
Yeah, that would be an awesome picture window for
the
sure.
Latitude of Clavius is 60 degrees south. Mm-hmm. So that's actually considered to be high southern latitude on the moon.
And it just go ahead.
Are we likely to find ice/PSRs there, or would that be further
Yes.
south?
In fact, this is actually the limit where you still have permanently shadowed regions. They're not as big and cold either, probably, as the ones that are at the South Pole or the North Pole, but they are still PSRs, permanently shadowed regions, and they are essentially tucked at the base of the inner walls of craters of impact craters on their northern side. And so there are therefore places on the floor of Clavius where the sun don't shine. And the thing I wanted to add is that Jack Schmidt,
Apollo 17.
Apollo 17 astronaut hero and geologist, has been advocating, along with Noah Petro, who is heading the Lunar Reconnaissance Orbiter mission, that we actually go to a place like one of these craters that are within the area of Clavius to actually learn how to explore PSR, permanently shadowed regions, and do sort of get back into the flow of lunar exploration with humans before we tackle something as challenging as the South Polar regions. So again, I think it's possibly too late to pull the plug on what Artemis 3 plans to do, which is the first human return with 2 astronauts at the surface of the moon, with the scenario that we're on right now. But very quickly, I wish we could shift gears towards setting up a base, because human astronauts are really not ideally suited to search for water in these permanently shadowed regions. I mean, they're extremely cold. Mm-hmm. The South Polar regions are extremely rough and steep. It's the lunar highlands. They have shadowing, that is, the shadows roll in and out very quickly and very dangerously. If you're caught in one of these shadowed regions, you could be trapped in shadows for long several weeks sometimes. Yeah. And that is very bad news for temperature and surface operations. It's, on the other hand, ideally suited for robotic exploration. So if I had things my way, and I would do more robotic exploration in the South Polar regions, target all these places where we're considering possibly extracting water someday, and assessing them systematically with robots, and then have humans be on the first maybe landing to symbolically mark our return to the moon, shift gears towards setting up habitats, and then doing pressurized rover traverses, but from a base that's a lot more manageable, logistically and operational.
And Pascal, have we ever actually landed anything on Clavius? Because as we're speaking, Firefly announced that their Blue Ghost lander successfully entered orbit around the moon, and if all goes well, they will land on Mare Crisium, the Sea of Crises, in early March. Meanwhile, in a couple of weeks, Intuitive Machines is launching the IM-2 mission, and of course, iSpace's lander is Resilience is also making its way. It seems like we're sending a lot of stuff to the moon, but have we actually landed anything on Clavius at all?
Clavius is still untouched. China, there's the rumor that they are targeting a landing, if not their first landing with humans, on the floor of Tycho, which is a very recent but very rough terrain-wise and steep in some places impact crater. Clavius, nothing yet. And as Rod and you guys were pointing out, Clavius has been on the map, so to speak, for a long time, thanks to 2001 and Space Odyssey. But the reason why Arthur C. Clarke picked that spot was just based on the general knowledge that this was a wide open space from which you could see the Earth in a very spectacular way, with the Earth low on the horizon, as opposed to like we had at the Apollo sites overhead, essentially. But there was otherwise very little known about the place at the time when it was proposed. But since then, a lot of things have been found at Clavius. I just mentioned the lava tubes and pits. I mentioned the PSRs, the permanently shadowed regions. But there's, for example, water, molecular water. Unlike at the poles where we're detecting mostly hydrogen first and then inferring that it's H2O. At Clavius, the SOFIA mission, NASA's airborne observatory that does infrared astronomy, which is now defunct, it's no longer being operated, but during its test run, it detected up to 418, I think, parts per million water molecule at the surface on the floor of Clavius.
So there could be more underneath.
There could be more underneath. It's unclear where what the origin of that water is. People like Pete Schultz, who's a planetary scientist, who's well known at Brown University, suggested that the Rutherford crater, which is relatively recent, was formed by the impact of a water-rich asteroid or even a comet, and so it could have just dumped a lot of water then, which is seen as a residual of that. But what that means is that the caves and the PSRs could actually have trapped some of this water if it's somehow concentrated there. And so lots of things for us to look into. And then in the recent study I did with a student of mine, Aaron Sampson, who's a sophomore at the University of Colorado Boulder, we find some potential volcanoes on the floor of Clavius that would be really exciting to explore. And then the different craters that you see across the floor of Clavius are of different ages. And so they themselves are going to inform us about, how the terrain and the subsurface of the moon evolves over time by exploring the different geologies.
So we need to go to a break, but just very quickly, Tarek, mares or horses, mares or moon seas?
Oh, wow.
Just so
Calling
it's
me
said.
out.
Just so it's said.
I thought I was award-winning, Rod. Wow.
You
Wow.
are, and we're just about to give you another one. In fact, it's the same one that both Pascal and I got.
The plural is Maria, not Maria.
So Pascal, I have to figure out a way to present Tarek's award that will best the way I presented yours by pretending to drop it on the stage. I'll have to think of that. Maybe I'll bonk him on the head with it or something. Okay, so
and congratulations, Tariq. You big time deserve it. I'm really happy.
Oh, thank you. Thank you very much.
all right, you guys knock it off here. We're going to go to a break real quick, and we'll be right back with my next question. Stand by. Pascal, you and I have talked a lot, mostly in the Martian context, but I think it applies to the moon too, about sortie missions versus longer stay / permanent or semi-permanent habitats of one size or another. And I'd like to get your collective thoughts on why that matters and how to accomplish it best, probably at Clavius.
Yeah. Well, sortie missions is what we did with Apollo, right? The nation had the commitment to landing a man on the moon and returning him safely by the end of the decade. That was achieved with Apollo 11, but then there were, some hardware developed and there was an exciting momentum there to do a little more on the moon, especially a lunar rover came on the line. So we went all the way to Apollo 17, and it was never the goal for Apollo to establish a permanent human presence on the moon. That wasn't what was at stake in the competition in the Cold War. And so what was done was sortie missions. You land here, and then next time you go to another interesting place scientifically, next time you go to some other place. Where you went didn't matter to the geopolitics of it, but it mattered a lot to the scientists. And so by landing in different places, you were sort of doing the science buffet of sampling what the geology of the moon has to offer. But it's really not an efficient strategy, even if you're a scientist, but especially if you're considering other things like geopolitics of being on the moon, the sort of our strategic presence, our long-term ability to explore the place, our logistics, just a logistics chain of going back to the moon each time. You really want to get into a mode where you are setting up an infrastructure as fast as possible. And so, the analogy, of course, are the Antarctic or Arctic bases. You set up a base, but a base in itself is not enough. A base would just anchor you to one point. It's a base plus a mobility system. So ways to travel from your base to sites of exploration, sites of mining eventually on the moon, sites of possibly tourism. So the idea of a base is really very important because it creates an infrastructure, a shelter, a safe haven for you at the surface of the moon where your operations are. I mean, some people propose a base in lunar orbit, but that doesn't really help with building an infrastructure to increase safety in your surface operations. And then once you have a base, everything is possible. So, with McMurdo in Antarctica, we can roam the entire continent with different mobility systems, C-130 airplanes for long range, helicopters for short range or twin otters, snowmobiles for on the ground surface short range roaming. And what I think should be decoupled is the idea that we do want a base on the moon, but we don't want it in the South Polar region, because the South Polar region is being focused on because we're looking for water ice there mainly. That's sort of the main draw for being there. And we don't know where we want to set up shop there yet, or if at all ever. And even if we found a place to extract water that was economically viable to extract, well, what you would want to set up there is a mine, not an exploration base from where you would roam around to explore other places. The terrain is just too difficult, the lighting too crazy and risky. And so those are two different things. And, you can look at the Arctic or extreme environments on Earth. You set up a town, but then you have different mines that you serve by roaming from there. I'm pushing for Clavius because I love the place at this point, now that we've studied it quite a bit. And the other beauty, of course, is that from Clavius, you have a very nice, gentle sloped corridor down which you could drive. And within a few days, you're at the South Pole of the Moon.
Huh.
Which is not true for a whole bunch of other high latitude sites on the near side or the far side. The lunar polar regions are very, very hard to sort of break into. They are surrounded by a fortress of very steep crater walls that are, contiguous. And all of a sudden there's a break if you're at the South Pole of the Moon and you drive northwest, you can break out of the polar regions on the near side of the Earth, of the metal, and reach the first big basin, and that's Clavius Crater. So I call it the Northwest Passage.
and you said it would take a few days to to make that drive? 2 days?
Not the original reconnaissance, of course. That would take a little while. But once you flag the route and you know that the terrain is safe, and it's a few days.
Well, I'm curious about where everything is in Clavius, depending on where you would want to set up shop. Because you mentioned that there's like a lot of other things. So you've got the water on the surface, maybe water underground. You're within driving, like a 2-day drive, a road trip, a weekend road trip to the moon's south pole. You mentioned that there are caves and pits and stuff like that. And then we saw in like the images that we've got on the screen for folks tuning in that there's a lot of interior younger craters as well. And I'm wondering if there's like a specific spot in Clavius that is the very sweet spot that you see, that it's like, it makes all of these different environments within reach. Because I think even I'm not a geologist, but I can see the advantage of being able to reach different types of terrain, different types of features, relatively. Steve, it's why when I go to the supermarket, I go to the one that's right by the Target, right? Because I got more options. So so I could see this for the moon too. But how close is everything else in Clavius if it's between Washington and Philadelphia?
So the candidate site, the candidate spot that we have in mind, you can see it on this picture. Again, the big round ancient crater that you're seeing, that's Clavius. All of it is Clavius, and then Clavius has a relatively flat floor, as you can see. And again, the crater that's fresh in the foreground, a bit to the right of it, straddling its rim, is Rutherford crater. And the spot that we're thinking about is immediately to the west of Rutherford, in that relatively tight but flat spot on the southern floor of Clavius. Mm-hmm. So that's where it is. And the beauty of that place is that you're now within just a few 100 meters to a few kilometers from caves. You are from several caves. You actually can drive up and out of Clavius crater right there in front of you. There's a breach in the southern rim of Clavius that's very drivable, with slopes less than 15 degrees, which is what the Apollo lunar rover could handle. So, and then from there, you drive on south, and the road to the South Pole is right in the middle of your screen there. It disappears below you. Right above the date, Friday the 14th, right above 14. Keep driving south that way towards yourself. You're headed south. So it's whereas if you were in the eastern part of Clavius, you can see that there's some pretty steep hills and cliffs and other places that are not so easy to get out of Clavius from. But it'd be a lot more site certification has to be done before we sort of say, okay, this is the spot. But and then it's right next to volcanoes as well, Yeah.
So lest anybody second guess Pascal's expertise on these images, I can personally attest the fact that this guy can stare at lunar or Martian images for 10 hours at a time, studying and memorizing everything while I'm trying to remember my middle name. Let's jump to a quick early break because I'm going to come back with a question that I expect a lengthy answer for. So stand by. Okay, so specific to let's say a medium-sized long-term habitat, so something that would house 12, 20 people, something like that. And I picked that number, by the way, dipping in my memory back to the U.S. Army plans for Project Horizon from 1958, because they were going to send 12 to 20 soldiers to the moon to live in their base that they thought they could construct in less than 2 months, which was absolute fantasy. Oh, and for $6 billion all in. But enough about that. So siting and construction and shielding, are you talking, in your mind, are you talking mostly about building on the surface, or maybe something of the surface split between the surface and down in a lava tube, or one or the other? How do you shield it against radiation and so forth?
Yeah, that's a good point. To me, the solution to shielded habitats are modules that you lay down at the surface, possibly on struts, like what NASA is actually thinking about for its first module in the Artemis program. So it's a bit off the ground, but it's on landing legs, if you will. Modules at the surface. And of course, to add radiation shielding, you sandbag them, as opposed to burying them, as opposed to somehow inflating them inside a lava tube. All of those things, I think, are fraught with risk, uncertainty, and even though you might gain in radiation shielding, now you have all kinds of logistical issues of getting out of those places. So I see as a reasonable approach to building a base to just do it at the surface, and then over time you sandbag it. You sandbag the modules. Sandbagging is easy. We do that already with robotic systems on Earth, around river or oceanfront levees. They scoop sand in the front and they poop a sandbag at the back. And they're very, very movable. And, so if you really want to reconfigure your base a bit, move things around, you can just, with a robot, take off the sandbags and put them back on. It's quite manageable.
That feels like a job for the intern, right? All right, go out, fill some moon dirt bags, right? And
no, actually, that's a job for you and me, because we go up there and they say, "Okay, what's your science background?" We just stand there with a sad look on our face, remembering our failures in college.
I would do that job in a heartbeat.
You
NASA bet. And Pascal, if you need like a sandbagger for the moon, I'm not promising to do more than like being able to do sandbags, but I can do that. Also, probably
be careful, because he does a lot of this kind of stuff on Earth, and he may recruit you to go up and do it somewhere here.
A sandbag carrier. Here's another thing. Clavius being so old, it's nectarian in age, so roughly between 3.9 and 3.85 billion years old. It has a very well developed regolith, very broken down. It's going to be the easiest stuff in a relative sense to just sort of scoop up and harvest for sandbagging.
I never thought of that. So on the pole, there would have been a lot fewer impacts, right?
Well, the poles, you have a lot of impacts too, except that they're in the lunar highlands, and then a lot of the craters at the pole will have dug up a lot of chunky pieces of dirt, including relatively recent craters. Clavius is very old. Of course, there are some recent craters in there, but it's I don't anticipate there being a problem finding sand, so to speak, to bag. A couple of things I think need to be, of course, brought up, which are the power. Okay, at the poles, the claim is that you can use permanently sunlit areas, but then when you think about it, you can't really seriously think of powering a base, let alone a mine, with a solar farm at the surface of the moon, with all the dust that's going to be kicked up, the Starship landings and launches. Solar panels are really fine for relatively small and initial infrastructures, but it's not the way to power a base. So to have a base, you need to go nuclear. And And that's basically the solution for at Clavius, where you no longer have the permanent sunlight. You have 14 days of daylight followed by 14 days of night. And to survive the lunar night, you need nuclear power. So I think might as well go down that road early. We need that for Mars, and that's recognized already now. The NASA Moon to Mars architecture workshop and team has already identified nuclear power on Mars as something that we have to develop for long-term presence on Mars.
Let me ask about that real quick, because I know that we've sent probes to Saturn, to Jupiter, out of the solar system entirely, with those radioisotope generators, those RTGs. And that's what I think a lot of people think about when they think about a nuclear battery for space. The Curiosity and Perseverance rovers have them. What kind of nuclear power are we talking about? Because the ones here, at 3 Mile Island are ginormous, and so there's one on the B line down to the KSC. You can see the smokestacks. Can we even build a small one that would power the base like this there?
Yes, we can. In fact, McMurdo, the American base at the South Pole, was initially powered by a nuclear power reactor.
I did not know that.
And in fact, it was hard to control. It was down half the time. So for a variety of reasons, and then also the U.S. wasn't wanting to encourage other nations in Antarctica to sort of go nuclear either as well. So the plug was pulled on that. But we have powered bases in places where, solar panels at the time at least were not up to speed yet, and so we're talking about a small nuclear battery, so to speak, and then actually a nuclear reactor, a fission reactor. And I grew up in France where 90% of power is produced by nuclear reactors. So I'm over the psychological barrier of nuclear power. But I think it's sort of the way to go, really. It's this now.
I'm not saying we should fear it. It's just I've only seen it, these ginormous things. I've never seen what a compact fission reactor would look like, right? Except maybe like a NASA rendering.
They're small.
Yeah. I also think space-based solar power has some future, especially for small dispersed infrastructures. I mean, if you have an outpost temporarily somewhere or it's a relatively small operation, then you could have space-based solar power, like essentially a solar farm in orbit, beaming down some power to you, because you have a lot of scattered assets. It doesn't become practical anymore to have nuclear power them, each one of them. And then, of course, space-based solar power can handle a bit of power support across the lunar night. But I don't see space-based solar power as being a solution that's practical once you have a growing base that's substantial in size, let alone on Mars. So I mean, that's just my take on it, but I'm not an expert.
Well, and looking at the Discord here, Out of Sync mentioned naval nukes, subs and ships. Those are fairly small reactors that create a lot of power. In fact, I remember
I didn't think about
when
that.
there was a hurricane in Hawaii years ago, and the power went out. I think it was in Kauai, which isn't a huge island, but it's got a large population. An American nuclear sub pulled up and ran cables out of a hatch and powered the whole island for a couple of weeks. They got their power back up. And the Soviet Union, back in the dark days of the Cold War, early Cold War, 60s, were sticking nuclear reactors everywhere. Most of them are still there. They're just kind of rotting away because they never took them out, but all over the Antarctic and up in the Arctic North and so forth. So that was in the dark days when these things could just like go bonkers. So they've come a long way since then for smaller ones. And of course, we've got the DoD working on, is it called kilopower? They've got that compact reactor that they've been working on for quite a while.
Would you want a nuclear powered, like a rover at Clavius? Because then you could like go off for like a month at a time, or like to go to all these different sites, go down to the South Pole, come back.
I mean, a robotic rover could sort of use an RTG type of approach to power it. Although I think currently pressurized rovers for crewed missions are thought of as being powered by fuel cells. And that might be the way to go for now. And of course, you would recharge them somehow at some point.
I think about Mark Watney in The Martian.
Well, in an RTG, so you're talking about a nuclear fuel pellet that isn't actually fissioning. It's just sitting there having heat converted to electricity, but it'd have to be massive for a crewed rover, wouldn't it?
Yeah, so I won't comment further on that, but it's a very lots of applications are possible, lots of options are available as well. But let
All
me
right.
say something.
Sure.
I think I don't want to just miss that, which is that why we even think of setting an infrastructure that's off polar if there's if we really think there's so much potential for mining and resource extraction, especially water at the South Pole. And I think the reality check that I want to sort of throw out here is that yes, there is plenty of water at the South Pole. We now know from the ShadowCam mission, which is a American camera on a Korean orbiter, that even these permanently shadowed regions don't seem to have a lot of exposed ice in them, and so the ice is most likely buried, at least within the top meter of the regolith, the soil, and possibly extending further down. But from what we can tell from these orbital surveys with neutron spectrometry, which measures how much hydrogen the soil contains, the equivalent amount of water in the places where you have the highest concentrations of hydrogen, therefore water, only reach a level of about 0.5 weight percent of water equivalent hydrogen. So what that means is that if you dig out 1 metric ton of lunar dirt in one of these areas that has the highest concentration of hydrogen, you get 5 liters of water at most. If you don't lose any of it out of that, 5 kilos, 5
Wow.
kilos per metric
Wow.
ton of dirt. To the Starship, when it launches, holds something of order 1,000, I think it's even 1,200 metric tons of fuel. If you wanted to refuel a single Starship with, say, 1,000 metric tons of water in the form of hydrogen and oxygen split up, you would have to excavate 25 football fields down to a depth of 1 meter to get 1,000 metric tons of hydrogen.
That is not a job.
of
That
water.
is not a job for this intern. I will not be doing that part. So-
Well, and my point here is that this is why I don't know if the water at the South Pole of the Moon, even though we say that, of course, in total it amounts to 100,000 Olympic swimming pools or whatever the number is, I don't know if it will ever turn out to be economically viable. And of course, the competing approach is bringing the water from the Earth. Any single landing of a Starship could land 100, say, metric tons of clean, purified water sitting where you want it with a tap at the bottom of the rocket. It's a water tower. And I don't know when we will have that on the moon with water extracted from the moon, if ever. And it's not just a matter of excavating the water. You have to, filter it out from the dirt. You have to contain it. You have to pipe it. In other words, transport it from the extraction site to wherever you want it, which means you have to warm it up. That's very power intensive to thaw ice at 50 Kelvin. That's minus 270 Fahrenheit, 370 Fahrenheit. So, I mean, it's a monumental task to liquefy the water and to transport it.
Okay.
So I'm not saying it's not possible. The question is, will it ever be economically viable? And to me, it's at the very least a huge question mark. And so throwing all our assets and setting up a base and all of this with not knowing the answer to this question, if it will ever be economically viable to extract the water on the moon, we should really decouple the two things. Establishing our permanent presence in a base we supply from the Earth and explore the moon, including the South Pole regions, and then keep prospecting for water with robotic assets at the South Pole.
All right, let's go to our last break and we'll be right back. Go nowhere. Every time you talk about flying up a starship filled with water, I think of this massive 300-foot, or no, how tall is Starship?
400
Upper
feet.
stage? No, just the upper stage. Lunar
I
Starship.
think it's 2 something, right? 250?
I think it's 180 or whatever, but this huge coffee urn with a little tap at the bottom that I would run out from my lunar habitat and fill up a cup of water and try and run back into the habitat and drink it before it freezes or sublimes. All right. So you kind of alluded to this earlier, but this is not NASA's favored plan. And
I don't know that it isn't. I've had discussions from folks at NASA headquarters this week Some were telling me, yeah, we're very concerned about RSRU. It's not, I mean, NASA actually did not choose to go to the South Pole of the Moon. This was something that was directed, or at least guided by the National Space Council at the time. And again, I think it was, on paper, it looks good. And it sounds like you're making the right move. I mean, everybody's so obsessed with living off the land and somehow making that the way to go. You have to really be very pragmatic about, how much exactly are you talking about being able to extract, and at what cost, and when, and by when. And all of these things, I think, were not really fleshed out before the whole bandwagon got moving towards sending people to the South Pole.
Well, and you wonder, regardless of the source of South Pole, how much of that is engineering driven, how much, if any, of that is science driven, which it doesn't sound like it is, and how much of it's geopolitically driven, which sounds like the majority of the cause célèbre, if you will.
Yeah, I think it's a geopolitical decision, which, the engineers are faced with a new novel challenge. But I think if it was just setting up a base on the moon and returning there, it'd be as challenging, but maybe more permanent, more durable, more meaningful in the end. The scientists, of course, are not pushing back too strongly, because at some level, wow, again, it's the same Apollo attraction. We're going to land in a different place every time. Instead of setting up a base, let's do the buffet science approach of sampling as many places on the moon as we can. But the truth is, if you understand how field science works in Antarctica, it's a godsend to have a base. A base is actually a good thing for science. It does not anchor you down. It's a springboard to other places. And so this is not necessarily understood, by all of my science peers. It's just one of those things where you don't convince yourself of the value of this unless you've experienced working in Antarctica or the Arctic, places where you need a base really to be safe and productive.
Well, you'd know more about that than most of us. Tarek, you got one more?
Yeah, I'm just wondering if there's one thing, Pascal, one thing about Clavius that you, when you get there, are going to go see first. Is it a specific?
He's going to look for the monolith.
Is it a cave? Is it just digging your hands in the moon dirt? What's the first thing you want to do when you land at Clavius and hop off the lander in your spacesuit and I guess give a stretch because it's a long trip. But anyway, after that, what's the first thing you'd want to go look at, either scientifically or personally?
Personally, I think I would like to run up that hill that's a little bit to the south and look at our infrastructure in the foreground down on the floor of Clavius, and basically take the equivalent picture as what was portrayed in 2001, A Space Odyssey. Maybe I can call that up as I have that as a background picture as well. If I can, I'll after the next break, I can put it up. But just because, here's a thing that turns out to be really interesting. We did not choose Clavius because of 2001: A Space Odyssey. We chose Clavius because it had some really good attributes as a place to set up a base. But however, this amazing connection that it would have with this movie, and the movie was a lot more than just, some artist concept. It was a real vision in our early steps in space exploration. The fact that reality would end up meeting fiction in such an amazing way. It's a bit like launching from Cape Canaveral and Kennedy Space Center. And comparing that with Jules Verne's From the Earth to the Moon, where he had predicted that launches would be from Florida. Mm-hmm. It's sort of at that level. If somehow we could start building a base at Clavius, it would be very attractive, I think, for the public to see that grow over time.
See, that's a very altruistic and picturesque desire for what you do. I would probably just write my name in the moon dirt and just write Tarek was here, with a Z instead of an S,
WUZ.
Take a selfie.
And let's not forget that Jules Verne also suggested that in that little tiny spacecraft that was accelerated to about 900 Gs as it was fired out of the big cannon, you were also supposed to take a bunch of chickens, and I do not want to fly 3 days to the moon with a bunch of chickens flapping
That's
around.
right.
My last question is, what are we going to see from you in the near future in terms of new research papers, new artwork, any books in the planning? What have you got?
So Aaron Sampson is presenting our geological map and human exploration target sites paper at the upcoming Lunar and Planetary Science Conference in Houston next month.
I love the picture you just put up.
Yeah,
this is what he wants to see. It's what he wants to see.
So the Earth is too low on the horizon there, because this would almost be a polar view of the Earth. The Earth is more like where the lunar module that's landing located, and the Earth would be a little less big. But anyway, so Aaron is presenting the geological map of Clavius. Daniel Sykes, who's a senior at University of Kansas, has discovered a bunch of caves inside Rutherford. Aaron found several outside of the Rutherford crater. So we one thing that we plan to flesh out in the near future is this route to drive from the south rim of Clavius all the way to the South Pole. We have a rough route plotted already, but we're talking about now, looking exactly at which boulders we're going to go around to get there. It's a lot of fun.
Pretty cool. Now, this is actually my last question. If you were to pick somewhere on Earth that would make sense for testing mobility systems for this region of the moon, where would you pick?
A place on Earth where we would test mobility systems for the moon?
For something, like this.
Yeah, I would pick, obviously, an open rocky desert with geologic features that are similar to what we would see on the moon. I mean, I work on Devon Island every summer, so of course I have a soft spot for that place. But there are a few places like the Atacama Desert, like even the Sahara Desert, the rocky parts of the Sahara Desert, like Chad, Mauritania. Regardless of what's going on geopolitically there, they are, from a landscape standpoint, very relevant to the type of terrain. And in fact, a lot of this is actually a nice opportunities for countries that don't necessarily have a high-tech space program to offer. They have in their backyards amazing desertscapes. They can really be part of this global community that's going back to the moon and offer their backyard as a testing ground.
That's a really good point, because there has been a lot of talk about surrounding the Artemis protocols and the Artemis agreements of, okay, you got us to sign up. What can we do now? So contributing real estate for research efforts would be a good thing. It's time for us to go think about moon bases on our own time. We've spent enough time with you now, and I've enjoyed every minute of it. And I want to thank you, Pascal, for joining us, and our audience for joining us today for episode 148 that we like to call Clavius Base, because it sounds cool. Pascal, remind us of all the online places we can track your adventures, if you would. MarsInstitute.net/HMP for the Health and Mars Project. We're also creating a new webpage for the HMP at the SETI Institute. It's not online yet. PascalLee.net for my personal stuff, some artwork as well, if you're interested in that. I'm otherwise on social media on X and LinkedIn. So that's pretty much it. All right.
Welcome input and questions.
Great. Tarek, where can we find you writing your name in the soil these days?
Well, you can find me at space.com, as always, of course. It's Valentine's Day, so maybe I'll be doing something nice for my wife. That'd be good. And
you better.
I know. And of course you can, if you're looking for video games, you can find me at you can find me on X and most places at Tarek J Malik there. And if you like video games, you'll find me at Spacetron Plays on YouTube. This weekend there's a live event in Fortnite. Very excited. It's going to be a little small thing, but we're coming up on the end of the season. Very excited for that.
Oh, sorry.
Hoping it's all about space.
Yes, how exciting. And of course, you can always find me at pilebooks.com or at astromagazine.com, where we encourage you to go download a free issue of Ad Astra Magazine. And there'll be an article concerning Pascal coming up in the next issue, actually. And maybe join the National Space Society if you see that as being appropriate. And of course, remember, you can drop us a line anytime at twis at twit.tv. That's TWIS at twit.tv. We always welcome your comments, suggestions, ideas, complaints, whatever you got, and Tarek will answer every one of them. New episodes published every Friday on your favorite podcatcher, so make sure to subscribe, tell your friends, like us, and give us reviews. We'll take whatever you got. And don't forget, we're counting on you. Yes, you, looking at you to join Club Twit in 2025. We need your support. The Twit Network needs your support. And besides supporting Twit, you'll help keep us on the air and get all kinds of cool extra things that you can only get in Club Twit, including the community there, which is fun and interesting and cool. And there's a lot of fascinating people there who have actually been commenting on our Discord. And we love every one of you. So thank you so much for coming along for the ride. You can also follow.
A question.
Sure.
Yeah. Sorry. What about you? Where would you like to land and see the moon from the surface?
Oh my God! I just want to go back up to your Arctic base again.
No, the moon I'm talking about.
No, I know, but see, when I was up there with you, I was on Mars, except I could breathe. I had normal gravity, and I wasn't being fried by radiation, at least not inordinately so. And I thought that was every bit enough. But if I had a choice, I'd want to go to one of the last 3 Apollo landing sites, I think, because I'd want to see the hardware. I want to go over and not touch for all moonkind, but just look at those artifacts from those first missions. Because when you really start, if you read about the space race days and remember exactly what we had at our disposal technologically when Apollo flew, not only is it amazing that it worked, but it's kind of terrifying in terms of how primitive that technology was. You know, the very first portable computers and all that kind of thing. It's jaw-dropping to me. And I'm actually, the new book I'm working on has some of that in it. And the more I think about it, the more I'm amazed that it worked. Let me just say, you can also follow the Twit Tech Podcast Network at Twit on Twitter, X, and on Facebook and twit.tv on Instagram. Pascal, thank you so much for joining us today. You're always a crowd favorite.
Well, what about you, Tariq?
Where's the orange dirt? Remember the Apollo astronauts found the orange dirt. I want to see the orange dirt on the moon. That's what I want to go. Yeah. So
Thank you, guys. Good choices.
Thank you.
All right. Take care, everybody. See ya.
At twit.tv, you don't have to choose between Apple and Microsoft. You can get it all in one place. Tune into Mac Break Weekly, iOS Today, and Hands on Mac for up-to-the-minute Apple news, app tips, and in-depth event breakdowns. For the Microsoft enthusiast, Windows Weekly delivers top coverage on Windows, Surface, Xbox, and more. And Hands on Windows offers practical, real-world advice. Security Now gives you the latest in cybersecurity insights for both, from product launches to software updates and all those great events. Twit.tv covers it all. Discover the best of both worlds at twit.tv. Subscribe today.